Yeah, welcome in this session about creating a flexible power system supporting ASEAN's cleaner energy future. I think a very interesting topic, part of the combined 76 Indonesian National Electricity Day and the Enlit Asia Digital Festival. I'd like to introduce our speakers today, Mr. Asnan Arifin, Chief Strategy Officer at TNB Research, Som Sahan Tanu, Regional Energy Director of GE Gas Power, Jeff Bernard, VP of Strategy and Management, PSM, and last, Matthew Rowe, Head of the Department Power Grids Asia Pacific, DNV. Yeah, welcome at this session. This session is hosted by General Electric. We thank them for their support. And during this session, you can ask questions in the chat box. So feel free to ask your questions, and our colleagues will take care of answering these questions. So my name is Leon Pulles. I'm a moderator of this session, working 30 years in the energy sector, and it is a very exciting journey our sector is making. And I think at this moment, all around the globe, you see the challenges of the energy transition. Today, we like to focus on the discussion how flexible generation can support that cleaner energy future. I think a very important topic. A lot of people are talking about renewables, but I think it's much more a system game, and we like to emphasize and explore that in this discussion. I'd like to invite the speakers to introduce themselves and to give a little bit more insights. May I start with Matthew?
Thank you very much, Leon, and it's a pleasure to be with everyone here today to talk about a really important topic. My name is Dr. Matthew Rowe, and I'm the Director of DNV's Power Grids business across Asia Pacific. I'm an electrical engineer by background and have worked across the world in all sorts of different projects, helping grids be smarter and more flexible. Maybe just to sort of set the scene, every year we publish at DNV a forecast of what we think is going to happen out to 2050 called our Energy Transition Outlook. And I think it's fair enough as consultants we get asked to predict the future. We're in a really unique position where we see all sorts of different insights. And there's some amazing facts in there about what we expect to happen to grid expenditure and the amount of money that we need to put into our grids over the next 30 years. In fact, globally, we predict it will double from about 400 billion USD at the moment to about 900 billion USD in 2050. But if you look at Southeast Asia, that number, that multiplier is significantly more. And actually, we predict that at the moment, if we're spending around about 9.4 billion USD across Southeast Asia, actually by 2050, we'll be spending 96 billion USD, and that's over 10 times as much as we're spending now. And that's because all of the changes and all of the different things that are happening in our system that our system needs to keep up so that we really can create a decarbonized energy system. The penetration of new renewables is an amazing thing, and it needs to happen as we decarbonize our energy systems, but it causes all sorts of amazing challenges to our system. We see less flexibility in how we dispatch generation, how we demand, we see less inertia on our systems, so we have less stable systems, and there's all sorts of wonderful technologies that I'm sure we'll explore today on the panel, on the different ways in which we can help meet these challenges so that we can really increase the amount of renewables we have on our system. So yeah, that's all I wanted to say, Leon, just to set the scene. So thank you very much, and I'm looking forward to exploring it.
Thank you, Matthew. Thank you. I think interesting insights here. Asnan, maybe you can introduce yourself and also give some start remarks.
Sure. Evening, everyone. Selamat malam. Good to be in this discussion. My name is Asnan Arifin. At the moment, I'm the Chief Strategy at TNB Research. My responsibilities include choosing and investing into technologies which might contribute to TNB's future. That includes battery storage, hydrogen, retail technologies, electric mobilities, etc. My career spanned across many departments in TNB. I've been in planning, I've been in investment they're interesting. Lately, 40 MB is our target, our sustainability pathway, our renewable energy targets that we have recently announced in the media. So the subject of flexibility is pretty much in our mind because of the renewable energy that we have targeted for Malaysia. We need to provide more flexibility in terms of the technologies that we have to do to provide these flexibility resources to accommodate more renewable energy in the system. So I'll stop there for a while. Then I'm very happy to answer questions and contribute for the foregoing discussion. Thank you.
Thank you, Asnan. Jeff, can you introduce yourself and share us some insights from your side?
Sure. Thank you very much, Leon. And thank you, everyone, for this opportunity to chat with you today. And thanks again also to the sponsor as well as Enlit for this technology festival. My name is Jeff Benoit. I am the Vice President of Product Management, Product Strategy and Marketing at PSM. PSM is an aftermarket service provider primarily for the gas turbine industry. And we're owned by Hanwha, which is a Korean company. And Hanwha's overall strategy for energy is to become capable of supporting across the entire infrastructure and ecosystem for sustainability technologies from solar all the way to the decarbonization of power equipment such as gas turbines. In my current role, and I've been in the industry for over 35 years, primarily in power, I am responsible for energy storage and hydrogen initiatives, specifically for gas turbines. Certainly, I recognize that we'll need to bring a broad group of technologies to address this decarbonization paradigm that we need to take care of. And we believe in terms of solidity of the grid as it transitions over to renewables and energy storage, that gas turbines can play a very major part in supporting that effort. So what we view is as we move forward in the next 5, 10, 15 years, an opportunity to be that supportive underpinning of the transition, particularly those areas such as Southeast Asia, which are aggressively and quickly looking to adopt renewables. And with that comes the challenge of, again, solidity to the grid. And we believe gas turbines can be part of that solution.
Thank you, Jeff. I think very interesting insights to further explore. Som, can you introduce yourself?
Sure. Hey, thanks, Leon. Thanks for giving this opportunity. Myself, Shom, I'm the gas power engineering leader for Asia, being in the power industry for 28 years, 14 years with GE. Really fortunate to be in a time when the energy sector is going through this transition. It's a very interesting time to be in. I'm sure we together, all of us are going to make some significant changes as we go. Certain things won't be viable today, but as time goes, things would change. Look, as a perspective, being an OEM into the space of renewables, into the space of gas turbines, what GE believes is, look, out of the 33.7 gigatons of CO2 that is being emitted today, significant portion, 41% comes out from the gas power industry, power industry. And if you look at that, the split is, there is a significant count of 27,000 terawatt hour of existing generation globally available today, which is contributing to this mix. But there are about 700 plus million people on this earth who are hungry for power. So if you look at that perspective, there is a population who needs power. That is where the new space of power demand comes in. And we are seeing a significant portion of that in Asia. But then there is another section where we have running assets. Managing these two to make sure that we are doing the right thing for the CO2 emission is going to be the right decision that every technocrat attached to this power industry would have to make collectively. And in GE, we believe that if the right optimal mix of gas turbines and renewables would do the trick. There are certain low-hanging fruits, and there are some far-fetched goals and targets with the fuel mixes around hydrogen, right? Where we can go ahead and make it really viable for our power operators to go ahead and run. So that's a teaser I will leave, and as we go, I think we'll iterate more on this.
Yeah, thank you so much. I think a very interesting statement, and maybe it's good to look a little bit further. When we look, we all are quite a while in the industry. When you look back 30 years, when you look forward 30 years, where will we then? And I want to ask Matthew to explore a little bit, how will our power system look like, to your view, when we look 30 years, 50 years ahead? How will it look like?
Yeah, I think that's a great question, Leon. And preparing our grid for today isn't going to help us. What we need to be doing is preparing our grid for tomorrow. I think if we look across Southeast Asia, there's going to be a few things that are going to become more and more important. The first is how interconnected our grids are. We're already beginning to see announced this week. We heard Singapore looking at importing hydropower from Laos. We're hearing more and more about countries across the region becoming more and more interconnected, and those interconnections are going to be really important. One of the, if you compare where we are at the moment compared to what's happening in Europe, Europe's an incredibly integrated grid where there's a huge amount of energy flowing, which adds more security and gives them more flexibility to their system. And without a doubt, we need to start thinking about this on a more sort of system level, allowing us to move energy around so that we can actually put it where we need it at the right time, so that people have a reliable and sustainable energy supply. So I think that's a really big key factor we're going to see change over the next 30 years. Yeah, I think another really important thing which we're going to see is the value of flexibility actually being valued and being quantified with a value on it. Because one of the biggest challenges at the moment is that we don't really put value on flexibility. We put value on baseload and the amount of energy that we can put on renewables on our systems. Things like the flexibility of a gas turbine or the flexibility of a storage device or demand side response becomes more and more valuable because we actually need to be putting energy on the system when we need it rather than when we can have it. And so what we need to see is the markets adapt and people looking at smart PPAs and smart contractual and commercial arrangements that will allow us to quantify the value of flexibility. And there's loads of ways of doing that that we've seen around the world, and we're starting to see a bit of it, but I think there's going to be a big change in how we quantify the value of flexibility services as well across the region. So yeah, I'll stop there and I'll leave it with those two because I'm sure other people will have comments as well.
I think, yeah, interesting insights, and I recognize what you're saying. When you look 30 years ahead, I think that are two interesting topics to be reached. I think when we look nowadays, a lot of things are already happening, and maybe Asnan, you can give us a little bit more insights what you're already doing as an operator, TMB of the national grid in Malaysia. What are you already doing at this moment, and what are the steps that you are taking on the shorter term?
Thank you, Leon. That's a question I always expected people to see, to ask a person like from TMB as the biggest utility in Malaysia and also one of the biggest in ASEAN. We have pretty much committed to our renewable energy targets and the commitment at the national level of a certain percentage of reduction, the Paris Protocol, a commitment to carbon reduction. So with that, utilities such as TMB will have to make certain targets. So we have recently announced our target of having 8,300 megawatts of renewable energy, mainly solar. We don't really have wind in Malaysia. There are pockets of wind potentials in Malaysia, but they're not much. We are pretty much solar, full of solar resources. So with that target, we in the utility itself, the renewable energy are open to everyone. It's not just TMB that can develop renewable energy. There are other private developers that can come in and provide renewable energy resources to us, TMB. But we as TMB, we have to think forward of the challenges, and we all know the challenges of having renewable energy, the problem of intermittency, the problem of variability. We pretty much know that problem before. And in fact, I spent time in system operation for 5 years, and the word flexibility wasn't there 10 years ago, I think, at least not to me. But what we must do is provide maybe, we don't call it flexibility at that time, but spinning reserve, voltage support, maybe ancillary services to support the proper operation of the power systems. Okay, but the word flexibility wasn't really there 10 years ago. But now with the advent of renewable energy, people are toying with the word flexibility. So we recognize, okay, maybe flexibility encompasses much more than what we used to, like spinning reserve, voltage support, ancillary services, backup power, startup, reserve power, things like that. Maybe it was there before. So when the word flexibility came in, it will cover everything else, almost all of them. So before we were prepared, providing for contingency losses in the systems, we are providing reserve power. But now with renewable energy is much more challenging because of the problems of intermittency and variability. And we have to pretty much change the way we operate the system. We cannot just be depending on, for example, gas open cycles to provide these services. We have to think more of that. At the moment, the way we run the system, because although we have a large target in Malaysia, 8,300 megawatts, the solar and the renewable energy that has come into the system is about maybe 2,500 megawatts. So with the current system, we are able to manage with flexibility resources of hydro systems. So we have hydro systems in Malaysia, about a couple of 3,000. Although hydro also, we have recently changed the definition also to include that as our renewable energy resources. But our hydro are there, and we have open cycle gas turbines that we can call in to provide that flexibility resources. But we know that will not be sufficient. Going forward, we have to plan for other additional resources. The things that we do now, like having pilots of battery storage, that will look into providing flexibility resources. We look into demand response, flexibility on the demand side, whether we have studied customers that can change their consumption based on our signals, based on incentives. So those are the things we are looking for. And the one thing that I have been, one thing that I have studied on couple of years ago is the value of having interconnection. It is a great pity because ASEAN countries do not really push for interconnections. We used to have, if some of us remember, ASEAN Power Grid Initiative. So we plan to connect Thailand to Singapore, although we have connections now, Malaysia with Thailand through HVDC and Malaysia to Singapore through 2 times 500 megawatt cable connection, but it's just that. We had plans to connect to Indonesia. We had plans before the famous Bakun Dam from Sarawak to Peninsular Malaysia, providing hydro power from Sarawak to Peninsular Malaysia. So that is something that I also personally think that we have to work on. That also provide flexibility, because if you can join efforts among the ASEAN countries, so this flexibility resources may be pooled among the countries. You as a one particular country, you don't have to provide the resources yourself. You can pool them together. So those are the things that we are doing now, and I hope the interconnection soon will come. So those are the resources that are working, and TMB is piloting it now. those technologies, and we are open to other ideas from this panel and from other professionals. Thank you.
I think it's interesting to hear the steps that you already make. I think it's important not to wait till the ultimate solution is there. I think you have to make your steps already, and good to see that you're doing that. And I also recognize the topic of interconnection. I think I'm from Europe, and there you see quite a good interconnection within the countries, but also with that interconnection, recently we saw that there was almost a blackout in Germany, and that I think that there people still do not really understand the challenges of adding more renewables to the grid. I think they are far underestimated. So it's good that we spend more in exploring, but also looking to technical solutions, to new concepts, maybe also some from General Electric. I think your company is quite broad active in the power sector. And maybe you can elaborate a little bit on the solutions in concepts or new technologies or new developments that you see from a GE, but can also be from other major technology supplier perspective.
So no, Liam, thanks. And I'll go back to some of the pointers that Dr. Asnan was mentioning. One being the interconnectivity among the countries, right? And then you have this headwind of having more of renewables on the grid. Who's going to be that muscle power holding the grid together, right? Look, I mean, what we see is when you look at this energy transition, one of the biggest equation on the table is affordability, reliability, and sustainability. Doing the right balance on these is the trick. And when I say that, and remember we had that discussion around 30 years, look ahead plan, but we're not going to wait for 30 years for a fuel to be affordable, for the grid to be compensating to the changes, or regulations to be more flexible to allow operators and gencos to stretch a bit more, right? There are some low-hanging fruits. And to give you a little blip of that, if you see, for example, you pick Indonesia, or maybe you pick some of the country in Asia, we still see a significant piece of the pie when you look at generation mix is still coming from coal, right? We still have coal adding power to the grid. Now, if you look at the math, you're talking of about 1,000 grams of CO2 per kilowatt hour emission from a typical coal plant, right? And now, again, every coal plant is not going to retire tomorrow. So what is the equation that is going to play? I think the equation is the generation mix. How do you do the right mix between a renewable, a gas, to offset a bit of coal so that you get a little bit of credit on the CO2 footprint you're putting in, right? For example, if Dr. Adnan talked about it, and I think Dr. Matthews, you also referred, when you bring in a gas power, natural gas power plant, right? Combined cycle, you're straight away talking about, and if I look at the numbers, it's about 45% of debit from a coal emission, right? And then you talk of a high efficiency gas turbine. So for example, in Malaysia, we have this 9H802, which is about 64-ish range, right? It's a high efficiency gas turbine today. That would give you a little bit more. You can talk about a 60% debit over a coal plant. Now comes the mix of, I'm sure Jeff is going to touch on that. You bring in the mix of hydrogen, right? You do little petty steps. You don't go straight away to 100%, right? You go in 5s and 10s and 15s, which are probably doable today. At least 5 15s are very comfortable on certain technologies. With that, you would straight away see 69-ish, 70% credit. You bring in renewable mix, you bring in battery, right? That credit will inch further, and you might go into the range of high 70s, close to 80s, right? So what I'm trying to say is, there are low-hanging fruits that we can work on, while hydrogen prices are becoming reasonable, right? So that's one side of the world, which is, in our view, the pre-combustion side of the world. When you look at the post-combustion side of the world, you're talking of carbon captures, right? So having CCUS or CCU kind of plants in place, which today is in a lot smaller scale, but they being modular and with the solid sorbent technology getting matured, probably that's a space where we can capture the emissions which are happening. So you're managing what you have already emitted. That's one side. The other side is, how do you manage how much I should emit, right? While you keep the grid more and more stable. I think those are certain equations which needs to be talked about, not only at a generation level, right? I expect that discussion to be at a little bit higher level. People who run the country, people who run the grid, they are at a more matured phase today to make certain discussions of those natures, right?
I fully agree. I think I've been working in the power generation sector for quite a while, and I think the time have changed. When you look to the position of the grid, the position of the power generation sector, but I also see the role of the government. I think in the end it's also about politics and about finding the right path to make these steps. You cannot just say, hey, power sector, power generation sector, you have to solve it. I think there are more players in the game, and I think the power generation sector is one. I think the grid companies are also an important player, but I think also the governments are an important player, because when you go back to your words, affordability, yeah, you can do a lot of investments when they do not make returns. And I think the game is also not so healthy, so sustainable. So maybe it's good to go to Jeff. And I think you already touched the topic hydrogen. And I think hydrogen is a very interesting topic. You see big plans all around the globe around hydrogen. I think it's good to put it in the right perspective. The role that hydrogen plays on the shorter term, but also can play on the longer term. So, Jeff, I'm very interested in your view.
Yeah, thank you, Leon, and Dr. Asnan. Thanks a lot. I really appreciate hearing the voice of the customer. So it's really important to see all of the things that TNB is doing for the power grid. Relative to hydrogen, I think that's the buzzword for today. And there's a couple of things about it I think we need to recognize. One, it's not a cure-all. It's part of an overall solution where hydrogen itself, depending on the color of hydrogen, if you will, can help and be used for both energy storage as well as then used as a fuel within the gas turbine. So that's one of the key things. I think you've seen, Leon, not only in Europe, but in Ireland relative to wind and renewables, when the wind stops blowing and there's not enough backup or energy storage, you run into just a massive change in the cost of power. Those are the type of things in small microcosm standpoint that needs to be addressed here in Southeast Asia. Now, I think Matthew also mentioned about the modernization and the interconnections with the grid. And while battery storage, I think, is definitely a part of the solution, you also need to look at grid-wise, grid-scale energy storage. And we see Europe moving in that direction. We see the beginnings of this happening in the United States. But it's one of those constructs where how can we leverage the installed fleet of gas turbines quickly to provide that reactivity, the responsiveness that we'll need as these massive quantities of renewables are being put on the grid. And we see that most every gas turbine can be retrofitted with advanced combustion technology that can incrementally, but very quickly and eventually fully decarbonize that asset. And with that being the case, a gas turbine is still a gas turbine, but it becomes hydrogen gas, but with a transition from natural gas to be a critical underpinning. With that, of course, comes the construct of legislative directives and regulatory incentives that kind of drive the timeline and drive the adoption, but they also provide the signals to Sean and myself, who are in the technology development area, where to focus and how to apply priority and resources. So what we are looking at PSM now with Hanwha, Southeast Asia is very, very dynamic, interesting, and exciting area to play. We do already have gas turbines operating today with our advanced retrofit technology that can be supportive of up to 35 to 40% of hydrogen by volume, done in a very easy way in terms of low oxides of nitrogen, without the use of diluent, which is always a concern where water is a scarcity issue. And we find that the roadmap to get there will take time. That certainly, it's not without its challenges, but we see it's very important as we move forward to leverage the assets that are installed today, decarbonize them as a part of the game, as well as what Sean said, is begin certainly in Southeast Asia to move away from coal and find that right energy conversion equipment mix.
Thank you, Jeff. It is quite interesting the role hydrogen can play, and I also I agree with you that when you look to coal, I think there were already challenges for banks to finance it, but the last week announcement that China is also not invest anymore in coal outside the home country. I think that has a massive impact on the region, and it's good to understand how this kind of changes will affect on the longer run. I'm very interested how Matthew is looking at that hydrogen roadmap on the shorter term, but also on the longer term, and also the role of storage. I think also maybe Matthew, you can elaborate a little bit more on the roadmap for hydrogen, how you look at that as DNV, and also the role of storage.
Yeah, I guess the thanks for those questions, Leon. And yeah, there's been some brilliant comments here from the speakers of what we can do with some of the different technologies, and we agree that gas will play an important role in our energy mix out to 2050, and that's without a doubt. And the question is how we can decarbonize that as part of the journey, and hydrogen will play a role in that. We see by 2050, it's interesting with hydrogen. So every year we publish this view of what the future is going to look like, and each year the amount of hydrogen we believe is going to be in our energy system gets bigger and bigger. So at the moment, we think about 10% of all energy around the world will be carried by hydrogen by 2050. Last year, I think it was 7, so we're slowly getting higher and higher. I think the more excited we are about it. And also as we see cost curves coming down as well, which is really what the driving force is for this. But really, hydrogen is going to be the only way in which we can decarbonize really hard to abate sectors. So there are certain industries and certain sectors that we will not be able to decarbonize without using hydrogen. So without a doubt, hydrogen will play a really important role in what we do and our energy system going forward. And I think it's great to hear about all the colors of the hydrogen rainbow that we have at the moment. But, unfortunately, as the other speakers commented on, things like green hydrogen is super expensive still at the moment, unless you've got some really specific cases. But the more we can focus as an industry on how we can drive down the cost of green hydrogen, the more impact we can make on our systems and the faster we can deliver a lower carbon energy system. I think energy storage is going to play all sorts of different roles. I'm just going to throw sort of a bigger picture, wackier idea out there, which is around vehicle to grid technology. Actually, the more electric vehicles we see on our systems, we inherently have more storage onto our networks as a result of that. If you take Singapore as an example, there's like 600,000 electric vehicles. And you imagine the amount of storage that you suddenly have available on your system if we can unlock vehicle to grid technology, and we can find a way of using batteries within the electric vehicles to actually be able to make our systems more flexible. And that is still a big topic that no one's solved around the world, but something that could really help change how we balance our energy systems. I think realistically, if we look at the journeys different countries are making around, have taken around energy storage, each country and each energy system is on a very different path. But what typically happens is they tend to start with shorter duration batteries, which are sort of 30-minute duration batteries, which provide some sort of frequency response. And actually the average duration of batteries around the world is about, if you look actually 3 years ago, it was about 30 minutes, and now it's coming up closer to an hour. So these batteries that were originally on the system providing frequency response are basically a type of synthetic inertia that allows us to help stabilize our systems better. But we are shifting away from that now globally, and batteries are getting bigger and bigger. And as we were talking about before, having more and greater volumes of storage capacity on our system. And that's because what we're beginning to see is the real value in storage. And the real value in batteries particularly isn't through frequency response services, it's through putting flexibility and having them co-located with different assets around the system to be able to have short duration flexibility. That's why we see them getting longer. So yeah, I expect we'll see a very similar trend here. There are certain countries, and it's great to see trials happening. It makes me really happy to hear TMB have got pilots in batteries. And we will see probably similar here, the duration getting longer and the batteries adding value in different ways. So yeah, sorry, a variety of different topics there, but certainly vehicle to grid technology is something I'm really excited about. And then probably seeing batteries around some sort of frequency response and eventually going out to providing flexibility onto our system would be my view of sort of where we're going to end up heading.
Thank you much, Matthew. I think it's very interesting to see these two elements, hydrogen, batteries, energy storage in the market. I was also wondering, when you look to other technologies like flywheels, and there are a lot of innovations around. What do you expect, maybe a question to all of you, of these new innovations on the scale of the next 10 years, but also maybe the next 50 years? How you see innovations playing a major role in the energy shift that we make?
I'll take a step on that question, if I may, Leon. We're pretty much have a focus on innovation now. At TMB, we're going to spend money on pilots and innovations, inventions. Coming to, I just want to answer, before that, I want to answer, just to respond to Mr. Sean, right? Remarks on gas. At the moment, TMB systems, in TMB, we have maybe about 50% gas. Some of you may recall that at one time, we are 80% gas, or 85% gas system in Malaysia. So that time we discovered gas in east coast of Peninsular Malaysia. So a lot of gas power plants. In 1984, we started with our plant in Kerteh, East Malaysia, east of Peninsular Malaysia. So we were 80% gas before, and then after that, coal starts coming in. So now, yes, we realize that to do this transition, we have to slowly transition from coal to gas. And I'm told, I'm not a generation background, but I'm told that some of our power plants in TMB, especially the new ones, can fire, and also can fire hydrogen, a hybrid mixture with hydrogen. So that is to be tested. I'm sure that there are vendors, equipment manufacturers that say that those can be fired together. But we in TMB research itself have been given assignment or task by TMB itself, generation, to actually test whether the existing power plants can co-fire with hydrogen. So we pretty much have to bank on gas some more now So we are 80% gas. Now we go to 50% or 55% coal. Now we're going to go more gas, especially looking at what I'm being told. Even today, the coal prices have gone up recently, international coal prices. So in Malaysia, our gas prices is regulated. So it's pretty much for cheaper than international prices for gas in Malaysia. So again, the pendulum has swung back to gas generation. So a lot of gas generation have more higher priority on the merit order. So gas certainly it will play a bigger role, but not as big as before, a bigger role compared to coal going forward, especially in the next couple of years. So on top of that, we realized that we have to attempt to co-fire with hydrogen. As Matthew has said just now, that it's really expensive now to produce hydrogen. And if you are going to just produce hydrogen using steam reforming, it's not worth it, right? You have to use green hydrogen, and green hydrogen is very expensive using the process of electrolysis. So at the moment, our generation company are looking into that. Okay, we are thinking for actually floating solar. There's solar. We have many water bodies in Malaysia that we probably can put solar panels, and then those can be used as an input to the electrolyzers. But still, it's very expensive. But the thing about for TMB is that even if we do that, we have to think of a way to actually transport the hydrogen from production to consumption, which is not co-located. So they are not, say for example, the floating solar is somewhere near our hydro stations. It has to be produced. It has to be transported to our gas power plant, which is somewhere else. So we have to think of those things before we go into hydrogen firing. So even if the hydrogen works, that can co-fire with our gas power plant, we have to think of the transport mechanism. So that is what, again, I'm sharing what TMB is doing. Regarding battery storage, I mentioned before that we are looking into grid energy storage. Our regulator has stated officially that by 2030, that there will be 100 megawatt battery storage installed in the system. So I'm telling you, it's all opportunities for all of us here. So 100 megawatt of battery storage for grid battery storage by 2030. But even before that, TMB has smallish kind of installation as pilots. We are testing, as we all know, that battery produces many value streams, behind the meter for grid services and also for maybe T&D deferral. So those are many services. But at the moment, we can do for behind the meter services. There are customers that have MD charges, maximum demand charges, that if we can go and install battery, then it will reduce the maximum demand charges. But as we all know, batteries are still expensive now. The payback is very long. So that's the issue, because Malaysian tariff is still cheap, relatively speaking. So it doesn't, the payback will be long, but we see that as we expected with solar also, massive reduction in prices before we see, and we believe that will also happen to the battery storage. So there are customers that we see that the payback is acceptable to them, because TMB also have access to customer load profile. We know who they are, and then can benefit from behind the meter storage. So that is for behind the meter. But what I want to say before what I want to say regarding battery storage for grid services, the thing in Malaysia is that we do not have that ancillary market services. Okay, there's no price discovery mechanism. It has to be a regulated price. So the thing is, how much do you pay for this independent battery service provider, for example? How much is it for spinning reserve? How much is it for voltage support? How much is it for T&D deferral? So for example, I'm told that in the UK, they have ancillary service market. So you just put it there, okay, tender, and then anybody can come in. Then they have price discovery process. But in Malaysia, there's none. So we have to depend on the regulator, and our regulator is looking everywhere to find a way to pay for these battery services. Okay, I'll leave it there for a while for discussion. Thank you.
Thank you for sharing the insights in the Malaysian situation. I think it's very interesting to understand your situation in more detail, and also the challenges of today. I also recognize these challenges. So I think it's good to learn also from other countries in the region, but also from other places on the globe. And I think I also want to look. I think we explored the system change quite well, quite in depth. My main takeaways were hydrogen and storage. I think they are really solutions, big important elements in looking to the future. But I'm also interested, what were your major takeaways from this discussion? What still you like to state as a final statement in this discussion? Jeff, may I start with you?
Sure. Yeah. No. Thank you, everyone. This has been a wonderful discussion, and I think, relative to innovation is going to drive adoption. If we look at where solar was 15 years ago, extremely expensive, but with the right regulatory construct, it drove the right priorities for R&D, which drove down the cost to the point where it's just extremely competitive. If we look recently at some of the non-subsidized bidding being done in the Middle East, you're at below $20 USD a megawatt hour, and just in terms of the cost, of very inexpensive, which drives and has been driving the adoption of solar in Southeast Asia. And when it comes to energy storage, I agree with Dr. Asnan. Green hydrogen isn't a panacea here. It's part of the solution. It will take time. There will be a transition. You need to have technologies with gas turbines and just the flexibility, the responsiveness, their current locations to be supportive of the grid to be able to co-fire. And with the type of solutions we're looking at, we don't view the gas turbine combustion technology as the barrier. We do see with some of our customers today buying solutions that offer up to 40% hydrogen by volume today, and the volumes are there to be able to support that. But you still need to have the innovation with electrolyzers, with transportation, the investments there to drive the paradigm shift. I think what we'll see here and what I'm hearing today is that we have a wide breadth of solutions. We have learnings from Europe that can help guide the more quicker adoption to a fully decarbonized system here.
Thank you, Jeff. And Som, I want to give you the opportunity to share your final thoughts, and also what are your main takeaways from this session?
So look, I love what Jeff said. What solar was a couple of years back versus what it is today. The same analogy applies to wind. You go back a decade, what wind was versus what it is today, totally different story, right? And a huge player is the support system to make it happen, right? So that's one piece. But I think one of the interesting pieces I'm taking away from this discussion is hydrogen combustion capability-wise, it's not a topic today. I think in our fleet in GE, we have about, close to 100 gas turbines plus, and we have done about 6 million operating hours on various blends of hydrogen. And these are mainly, going back to Dr. Asnan's comment, these are mainly gas turbines sitting very close to refineries, where hydrogen is a byproduct. They need to consume it, right? It's something which is coming out of the process. And what better way than produce it, convert it as a power, right? So when you look into refineries, this makes a huge sense. But the moment you bring that same gas turbine miles away, right, kilometers away, transportation becomes a big deal. It's not only the temperature management, but also the piping. The moment you go beyond certain blends of certain percentage of hydrogen, the pipes are no more rigid then, right? The hydrogen has the capability to penetrate into the pipe, and embrittlement becomes a topic then, right? So you got to talk about, hey, how do I put in a layer inside the pipe internals so the hydrogen sits there, it doesn't get into the metal, right? So those are topics which will come in, but I think the takeaway I'm taking is let's start small. Let's not sit back waiting for somebody to do something 30 years from today. We can do something today. We can start with a simple cycle. We can put in high efficiency gas turbines. We can reduce the generation mix in coal and start pumping in more of renewable, more of storages, more of gases. As we go to the next decade, I'm sure hydrogen would become a bit more cheaper than what it is today. And I think we will hopefully be in the industry that time, and we will be making history with that. So I'll leave there, Leon, and thank you for the opportunity.
Yeah, thank you. Thank you very much for your insights. Matthew, your turn to share some final thoughts.
Thanks, Leon. Yeah, and thank you to everyone for sharing all your views today. Thank you to Enlit and GE for sponsoring. I mean, for me, I think it's brilliant to hear how much effort and hard work and inspiration is being put into making sure the way in which we're using gas on the system is moving towards a decarbonized system. I think it's great to hear from all the speakers on the panel today of the steps that we're taking to be able to decarbonize that part of the industry. And at the same time, there's all sorts of great technologies that are going to help us really deliver our transition to net zero. And I think it's become apparent, like, I feel really fortunate to be sat in the ASEAN region as we go through this transition, because we've got some brilliant stakeholders who are already trialing these technologies, who are already being able to put them into place. And I completely agree with Jeff that innovation is really what's going to drive that. And it's the right mindset, and it's thinking about this as a wider energy system and thinking about it in an innovative way. It's how can we deliver this together? And that will come through greater interconnection, sharing ideas through events like this, and really sharing with each other what we can learn and helping each other to make that happen. So yeah, all sorts of different insights through gas through to new technologies and the way in which our mindsets allow us to make all these wonderful things happen. So thank you very much.
Yeah, thank you, Matthew. And Mr. Asnan, for you, the last words, your final thoughts. I think I'm very interested what you're going to do tomorrow, what you have heard today. So I think in your position as a grid operator, I think it's very important that you are prepared for the future. And of course, you can have your long-term view, but it's also interesting what you start to do tomorrow. You already shared some insights, but I want to give you a last chance to also, what are your plans for tomorrow to implement?
Thank you, Leon. I pretty much enjoy insights. Although discussions such as this 1 hour is always insufficient for us to go many points, but I've managed to capture the gist of it. You know, hydrogen, gas co-firing, what Jeff and Sean mentioned, and Matthew from DNV. We always have communications with DNV. We know, there are tons and tons of reports that are done by DNV. Well, tomorrow, although I'm from DNV, I'm on the research side. So we will have to continuously innovating and look for solutions. Okay, we have this energy transition and then net zero objective that recently been announced, but TMB has to go net zero by 2050, much like our oil and gas big brother Petronas. By 2035, we have to have 45 reduction in emission intensity, so that removes coal power plants. So when you remove, when you no longer have coal power plants, and then you have gas power plants, and you are coming in with solar, definitely flexibility and innovation into flexibility is pretty much on our mind. So with that flexibility on the supply side, flexibility on the demand side, flexibility on the network side, or even flexibility on the system side. I mean, in terms of market, having what I used to hear what people call adaptive flexibility, meaning that system also have to change. Maybe Malaysia must move from regulated to a market mechanism to enable flexibility. So those are the things that we do now. So it's pretty much a lot of opportunity in Malaysia to innovate and to invest. especially because we have targets to achieve a certain net zero target by 2050, net zero target by 2050. Therefore, we have to include renewable energy more into the system. Therefore, innovation into flexibility is pretty much welcome. Irregardless, I'm technology agnostic. I mean, it can be battery storage, it can be demand response, it can be advanced gas turbines, it can be hydrogen storage, even pump storage, or interconnectivity. We are open to it. So thank you very much. Okay, I was hoping that my Indonesian friend could be here. They can share his experience. Unfortunately, he's unable to. So with that, Leon, thank you very much.
Thank you, Asnan. And yeah, we are also looking forward to meet in real life. I'm looking forward to the next year event in Thailand. I think we now are in the situation that we have the digital session and to discuss with us, but it would be nice to sit together and drink a beer and talk a little bit longer about this very interesting topic. I want to thank the audience for listening to this webinar, and also thank you, Jeff, Matthew, Som, and Asnan for contributing to this very insightful discussion. I think it's not the last discussion. It's one of the major topics about the energy transition that we will have, and the Asian region is a very exciting one looking to this topic. We can learn a lot from outside the Asian region, but we also have to be aware of the typicalities of the Asian region. And I think that's also a very important element. GE, I would like to thank GE as host of this session, and thank you all, and see you during the next session.